Good morning all. So today we will be discussing on a new causal influence or a causal technique which is called as the gray influence analysis. So we have named it as GINA or GINA in short form. We have not used GIA because GIA is usually used as a like short name for gray incidence analysis. So we have proposed this as a this name as GINA or GINA. So it is called as gray influence analysis technique, and this is very useful for any researchers who is working in the area of marketing or supply chain or any other domains in the particular areas where causal modeling is required, because you are identifying a particular set of factors or maybe a set of drivers or set of enablers for a particular situation or particular problem, and you want to identify the level of influence among these factors, and you wanted to identify which are the factors which are playing a major role in the system. Why this influence analysis or causal analysis techniques are very important? Because these techniques will help to understand the primary reasons for being having an effect and how we can control this. So this causal modeling or the influence analysis techniques are like very important in any kind of, particularly with marketing and supply chain research. So we have practically given an example of a problem in the marketing domain, which is the problem of greenwashing. Okay, so what is greenwashing and all I will be discussing in the later slide. So before that, we will be giving a prior introduction to the gray influence analysis. So if you are like new to this area, the gray theory and the related methodologies, you can watch one video on gray incidence analysis and basics of gray theory I have done in the previous lectures. So you can please refer to and you can listen to that. You will get a brief idea of what is gray theory and what are the methodologies that uses gray theory. Okay. So directly we can go to the influence analysis technique, which is called as a GINA. So it is like basically built on a model which is called as the gray input output analysis. So based on the theorems and the definitions given in the this gray input output models, you can refer more to the textbook of Sifeng, Liu and Wiley. Okay, so this textbook I have already told about this textbook in the previous lectures also while I was introducing the gray theory. Okay, we can directly go to the influence analysis. So this is the paper, the introduction to gray influence analysis. So the YouTube video link also I have given in this, and we can see that we have given the application to marketing and supply chain research. Okay. So this is the proposed methodology, and why this methodology is needed, because there are many other causal modeling techniques. As we know, there is ISM, DAMATL and so many other causal modeling techniques are there. So why one more addition to that is required? Because it is required because most of these techniques they can analyze data when there is limited number of responses, because most of these causal modeling techniques either in the ISM, DAMATL are the like mostly used influence analysis or causal modeling techniques which we are using for the multi-criteria problem. So these techniques usually uses the input from the expert or from the collected data, which is like small in number, usually around 10 responses, 5 to 10 responses. You can collect it and you can take the average of the responses and you can make it as the input for the model. So input will be the influence of or the cause effect relation between one factor over the other. This is the input we are taking for the model. But usually when the case there are large number of responses, so a study become more like valid, or we can say that the study become more reliable when there is large number of respondents. And large number of responses, those responses are also valid. Okay, in such cases it will be difficult to incorporate into this normal causal modeling technique. So we can go with the new methodology called the GINA methodology. So we are aggregating the responses in a particular way that there will not be any data loss. And what is the problem if you are taking the average in case of you have a large number of responses? Because there will be data loss, right? Because you are only taking the average of the responses, so that will be like problematic. Because if 20, maybe you have 40 responses Suppose that you have 40 responses you have collected. Of 20 of them, they have given a minimum value, lower value, and that means that you can, in a linguistic scale, you can record it as 1. Okay, and 20 of them have given a higher value. So in a 5-point Likert scale, you can indicate as 5. Okay, so 20 people have indicated 5 and 20 people have indicated as very low. That is the influence of one factor, particular factor over the other. Okay, then while you are averaging the responses, what you will be getting? You will be getting a value 3. That means that there is a medium level of influence. But actually that is not true. So that we should avoid in such cases, so that we should not have these kind of recordings or responses, we can say that, because once we have not given any response or any value, we have not given as the average value, but still we get it as the level of influence of one factor over the other is the level of average. So these kind of problems comes when you are simply aggregating the data. So you can give the weighted average of the responses also, but these are all not effective techniques, because still there will be data losses and there will be biases also, because there are one response, if you are not able to remove or you are not able to clean the response properly, you will be ending up with this kind of biased responses. So how we can handle large amount of responses in a causal modeling situation, and how we can find out the important relations in a causal modeling particular technique, that we can use the gray influence analysis model, or which is in short we can call it as the GINA. Okay. So this is already given, like this technique overcomes the limitations of the existing techniques such as the ISM and DEMATEL. And why? Because it will be having data losses by aggregating the initial responses. So what will be the responses we will be taking, either in the scales of 1 to 5 or 1 to 7, the Likert scales. We will be collecting the responses based on the influence of one factor over the other. So this is the basic input we needed for analyzing a causal problem. Okay. So this technique I will be discussing. Basically, we will start with the gray influence analysis technique. We will start with the sum of the definitions. Okay, so what are the definitions which is like basically involved in the gray influence analysis? I already told, because this technique, which is an extension or which is developed from the base, which is having the base of the gray input output analysis. So these definitions are also based on the gray input output analysis, which is a MCDM technique based on the gray theory, which is you can avail this technique, the definitions and theorem regarding, or more details you can get it from the gray information, the practical book from the Sifeng Liu, published by Springer, from Sifeng Liu and Weilin. So this book is available. You can just search on the search for the book, and you can refer the book for more details of the gray input output models. Okay. So, but we are the causal modeling situation, we are developing from the base of that, but the technique is different entirely, because we are using only the what are the definitions which have been used for building a basic gray input output model. Okay. So this gray influence analysis uses the basics of gray input output model. So they can be found in this book, which is written Liu and Forrest 2010. Okay. So we will be going for the first definition. So what we are representing? So this an into mark inside a circle. So this is representing, what it is representing? It is representing a gray number. So gray number will be having a lower bound and an upper bound. Okay, and usually with gray numbers are represented in the limits are represented in, usually we are showing the limits in the square brackets. Okay, so these two values will be there. And for a gray number, one is the lower bound and the upper bound. So lower bound we will be showing with the symbol with an into mark inside a circle, and there will be a line below that. Okay, and there will be a line above that is the upper bound, showing the upper bound. So what is the input we need? We need the first influence relation, that is the influence of one factor over the other. So usually it will be represented in the form of a matrix, that will be factor I over j. What is the influence of factor I over j, which is measured in a scale, in a Likert scale from 1 to 5, or you can take it 1 to 7 for more differentiation. Okay, so this is the first definition we are seeing. This is the influence relation we will be representing in the form of a matrix. Okay, so let us assume that xij or gray number xij be the influence as indicated by gray number xj. Okay, then the sum of influence that a factor j impart on the system we calculate as that is we are representing by the gray number aij equal to the gray number xij divided by gray number xj. So what is the meaning of that? The particular influence of a factor I over the j divided by the total influence that a factor j impart in the system, that is xj. So we are giving the particular influence, that is I over the j divided by the total influence that a factor j impart on the system. So this is we are indicated by the gray number aij. It is called as the direct influence coefficient. Okay. So this represents the degree of influence of factor j over I, indicating how closely they are related. So this is the indication of that. Okay. Now the matrix representing all the values of aij can be represented. This also we can represent in the form of these values of that is a particular xij value divided by the sum of influence of the factor j, that is xj, that can be calculated for all the values, and it can be represented in the form of a matrix. So this is called this constitutes the definition 3. Now coming to definition 4, now we have the matrix A. So A in bracket, that gray number that indication is shown, this represents the matrix of the direct influence coefficient. Okay. Now we calculate the complete influence coefficient. How will be calculating that? That we are calculating I minus the gray number or the gray matrix of A, inverse of that minus of I. Okay. So this value will be determining, or this matrix will be forming, and this is indicated by the matrix gray matrix of B. Okay. So B gray matrix is indicated by the small b, B11, B12, etc. up to B1n to up to Bn1, etc. etc. up to Bnn. So this is represented by the gray matrix of B. Okay. So this constitutes definition 4. Now we can assume that the matrix, the B matrix I minus A inverse minus of I represents a complete influence coefficient. Okay. So then we calculate the gray responsibility coefficient of the ith factor. So this is the complete influence matrix we can say. Okay. So or we can say that it is a complete influence coefficient matrix. Okay. So we calculate the gray responsibility coefficient. How will be calculating gray responsibility coefficient? It is we are taking the sum over j equal to 1 to n. Okay. So j equal to 1 to n means that we are calculating the row, the sum over the row. Okay. So bij of gray number divided by 1 by n of sigma I equal to 1 to n. I equal to 1 to n means that we are taking the sum, that is the I for each row, that means the column sum. Okay. For each row 1, row 2, etc. So that means the column sum. Now we are taking sigma j equal to 1 to n. That means j equal to 1 to n, we are taking the sum of each column, that means the row sum. Okay. Sum over a row. Sum means it is representing the sum in a row. Okay. So you please understand that j represents the column, but sum over the j it will be the row sum, and similarly we can say that I represents the row, but sum over the I it will be, you are taking the sum, that is the column sum. Okay. Okay, so this definition, next definition. So this we are calculating the gray responsibility coefficient. Now we are calculating the gray influence coefficient. Okay. So how will be calculating? We have the B matrix. Okay. And it is representing the complete influence coefficient matrix. So we can calculate the another value called as the gray influence coefficient, which is represented as Vj of, that is gray number Vj. So it will be indicated by sigma I equal to 1 to n Bij of the gray matrix or Bij value divided by 1 by n into I equal to 1 to n sigma j equal to 1 to n Bij, that gray number. Okay. What is the indication here? Denominators are the same, only numerator is different, right? We can see that the denominators are same. Ui, the gray number ui or the responsibility coefficient means that we are taking the sum over the j equal to 1 to n Bij of, that is a particular gray number, and for Vj of the gray number, what will be indicating sigma I equal to 1 to n bij. What is the meaning of that? We are taking the sum over the row. Okay, so first, sum over the column. Okay, so for first one is the row sum, second one is the column sum. Okay, so that is the difference between that. So with the practical problem, you will be more clear in understanding. So gray responsibility coefficient, what is the indication of that? Responsibility coefficient means that how much a factor I can influence other factors. Okay, and what is the gray influence coefficient? How much the factor J is getting influenced by other factors in the system. Okay, so these are the indications. So we have used different notations only, I and J, because to distinguish between. Here we have used UI, here we have used VJ. Okay, so this is for distinguishing purpose only, because both we are indicating I, there will be confusion. Okay, so for that only. Now we can calculate another one called as a gray important coefficient. So how will be that, how much a factor is important in a system? So it is normally how we can say that it is the sum of both, right? How much it can influence the system or how much it is getting influenced by the system. So that represents the factor is important or not in the system. Either it is influencing or it is getting influenced. So factor is having any role in the system. So how much the factor is associated with the system. So that we call it as the gray important coefficient, Tij. Gray number can be calculated as, simply you can add the gray numbers Ui and Vj. Okay, so we will be discussing on the GINA evaluation, how we'll be doing and why we are the advantages over ISM and DEMATL. Here one table is shown with the recent application of ISM and DEMATL methodology and what people have people have conducted the research in the recent times. So some of the recent references has been cited there. You can refer to the paper for more detail. So this paper link will be given in the comment section. Okay, so right now it's not published. Okay, it's received revision only. So once it is getting the final version, I will be giving the link to the paper. Okay, so for your more reference. Okay, then identify the factors in a study. So first one, what to implement in a GINA methodology? We have to any system, either a supply chain environment or a marketing environment. We have to understand which are the factors involved in the system. Okay, so you identify a set of factors. Inside that factors only you will be trying to find out the influence relation. Now obtain the influence relation among the factors. So how we can get the responses? We can directly go for a survey based study. Okay, so you can go for a survey based study and you can collect the responses, that is the influence of a particular factor over the other. You can ask us a question and you can indicate in a scale varying from very high to very low. Okay, on a 5-point Likert scale or maybe a 7-point Likert scale, if you want to distinguish more between that. Okay, usually a 5-point Likert scale will serve the purpose. That means that very high will be there, high, medium, low and very low will be there. Next, what we'll be doing? So I am telling about how we'll be collecting the responses. Okay, so you can go for a survey based study and you can collect n number of responses. That is the advantage or beauty with the GINA methodology. You can have you can incorporate a large number of responses. Okay, after data sorting, so you can sort the data and you can clean the data after collecting these responses, and you can remove the biased responses. This you can do as a manual process, or you can use any kind of brainstorming or a kind of Delphi technique to sort out the data also, because once the responses are biased, it will be creating problem. Okay, so you can do it a manual sorting also. You can see that responses are critically biased, or if a person is giving only value of 1 or value of 3 for all the influences, so you can clearly understand that there will be a bias. Okay, so it is better to remove that kind of responses in the early stage as possible, because otherwise it will affect the entire process. Okay, so next is the influence relation among the factors we are obtaining. Now we can find out clean the responses. So this is a very important step. Cleaning I already told, because you are including biased responses in the study, it will critically affect the result and conclusions. Okay, so convert the influence relations into gray scales. So that is the next one. So how will be converting that? I already told there is a conversion scale. So we are calculating from very high to very low. So we can have a conversion scale here. So very high means that 7 to 9 we can give value, and very low means that we can give value from 0 to 3 or 1 to 3 or some scale you can give. Okay, so this is like here you can see that this is represented by a gray number, with the lower bound and an upper bound. Okay. Now we have to aggregate the influence relations in gray scale. So how will be calculating? So there are different operations with the gray number. You can refer to the gray theory textbook for more more about the gray operations. For simple additional operation I will be telling, because average is a simple addition, and finally we will be dividing by the number of responses we are adding. Okay, so this is simply we can take the lower bound, the average, or the simply we can take the we are not averaging the responses. I am simply we are adding the responses only, right? Averaging the responses will create loss of data, so we'll be simply adding the responses. So we are accumulating the data only. Okay, so this what is the advantage with that? We are not taking the average, so that some responses will not be recorded in that. Okay, so we simply will be adding with the lower bound and the upper bound. Okay, so lower bound all will be added together and upper bound all will be added together. So this represents the sum of the gray number. So it's a simple addition of gray number. So a gray number addition means that it will be the adding the lower bounds and the adding the upper bounds, and the total will be represented as the sigma values. Okay, so you can see that this is the lower bound sum and the upper bound sum. Okay. Now how we have to whitenize the value. Whitenize means that it is a similar process to defalsification. We are converting a gray number to a crisp scale, and we will be having the conversion scale. Okay, so here we will be, here is the process where we are maintaining the or we are avoiding the loss of data using 3 conversion scales. One, we are using the critical model whitenization, another is the ideal model whitenization, and the most typical model whitenization. Okay, so what is critical model whitenization? Critical model whitenization, we will be taking the lower bound of the values only. Okay, we will be taking the lower bound of the values only, we will be taking the sum of the values. Okay, this will be taking. And what is the ideal model whitenization? We will be taking the upper bound of the values only. Okay, and what will be the most typical model whitenization? We will be taking the average of the lower bound and upper bound for whitenization. Okay, so now we have the gray number. We are converting that based on that. How will be converting? We will be converting based on 3 conversion scales. One is the critical model whitenization, another is the ideal model whitenization, and the most typical model whitenization. Okay, so why? To avoid the data loss, because we are taking the lower scales and the upper scales and the middle scales also. So, or the most typical scale, that will be the most particular value which is to be associated. Okay, so calculate the direct influence coefficient. Now you can calculate the direct influence coefficient for all the 3 matrices. Now we have 3 crisp score, which are the one ideal model, one correspond to the critical model, and the third is corresponding to the most typical model. Okay, so we will not be losing the data. We are using 3 different matrices. Okay, this is represented as we can convert. Okay, so the direct influence coefficient, and we can see that we are converting these values into a form of AK matrix. So AK, K is representing 1, 2, 3. One is maybe we can represent as ideal, critical, and most typical models we can represent. So 3 different matrices will be obtaining based on the direct influence coefficient matrices. Okay, so now what we can do, we already told, we will be calculating the B values, B gray number. Here K is involved because 3 matrices are there. So K is indicating 1, 2, 3, because one is representing the ideal model, another is with the critical model, and third one is with the most typical model. So I will be calculating 1 minus A, inverse of that minus of I. Okay, so this is what. So here K is also involved because there are 3 different matrices. So indicating them, we are using the notation K. Next is calculate the gray responsibility and influence coefficient. Okay, so we already told how we will be calculating. First we will be taking the sum over j equal to 1 to n Bij divided by the sum over I and j Bijk. Similar way, the influence coefficient also. How we will be calculating? I equal to 1 to n Bij divided by I sigma over j Bijk divided by n. So this is the value. These are the values Uik and Vjk, and finally we can take the gray importance coefficient. Or how we will be calculating that? We can add the values Uik and Vjk. We will be getting the gray importance coefficient. Now, how will be calculating the most influential drivers? We can say that we can, based on the values in Tijk, we can identify the most influential factors corresponding to the critical model, ideal model, and most typical model. And how we can aggregate this? We have three values now. How we can aggregate? We can similarly use the principle. We mostly use here it is the Tijk, that is with the this is mostly used in project management technique like PERT and all, because we will be having optimistic time, pessimistic time, and most likely time. So we'll be taking the most likely time is the most probable time, or we can say that the most typical model is having the more chances of. Also, that values are most close to reality. So typical ideal model is like most ideal one, which is like which cannot happen all the time, and the critical model is the most worst one, which also cannot happen all the time. So we can give 1 priority to them, Tijk1, Tij of 1 and Tij of 3, 1 1, and we are giving 4 time weighting to T, that the most typical model, that is Tij1 plus 4 into Tij2 plus Tij3. So the both then ideal and the critical we are giving least weightage, and we are giving most weightage to the, or weighting to the most typical model, and divided by L. You will be getting the values, the most influencing factors will be understanding. Okay. So usually we can use an L as an arbitrary number from 1, 2, 3 up to 6, because here we are having 6 only, because 1 plus 4 plus 1. So total we are taking the weights 6 times, so we can divide it by 6, and you can use any value 1, 2 up to 6, so there is no problem. Usually we can use 6. If the values are you find to be very low, you can magnify it, you can reduce the number, like you can divide by only 5 or 4, you will get a magnified response. Okay. So based on the values in the Tij, you can easily understand which are the most important factors in a system. Okay, and we can apply Pareto Principle also. What is a Pareto Principle? 20% of the factor response for the 80% of the problem. So we can take, if there are 12 factors, you can find it about the most important 20% of the factors. So 12 into 20 by 100 you can calculate, and decimal places are coming, you can round it off to the higher digit. So that many number of factors. So it is maybe coming 2.5, you can round it to 3. So we can say that the 3 important factors, or 3 factors which have the highest Tij values, we can take it as the factors which are having most importance in the system. Okay. So this is the way we will be doing the problem. So here a greenwashing problem is given. What is greenwashing? Greenwashing means that in actual cases, the firm has to report their sustainability performances. So greenwashing means that they will be showing more performances than they actually do in a company regarding the environmental protection, or maybe with the social issues, or wherever they are interacting, they will be projecting more than the actual. So this kind of problems usually is prevalent in companies, because most of the companies want to show their product like more eco-friendly, or they are implementing a very good reverse RL network, reverse logistic network, and so that they want to attract more customers. So these kind of problem will happen with the companies when they wanted to project more. So for that they will be showing that they are doing a very good performance in case of sustainability, either in the case of environmental sustainability or maybe social sustainability, social aspect of sustainability. They are supporting societies, they are supporting education, they are preventing child labor. So these kind of things they will be projecting more because they want to attract more customers, because now many customer stakeholders are interested in the companies, or they want to invest, or they want to, the investors as well as they want to invest in the companies, those companies which are having a very good performance in the environmental as well as social aspects, or we can say in a total sustainability aspect. Okay, so this is the reason why many firms try to greenwash their product, that they claim that they are doing these kind of activities, like they project it, but they may be just doing for the namesake, or maybe the mandatory CSR they are following. Okay, so this kind of problem we have taken, and we have identified the different drivers of greenwashing. Okay. Okay, so this is the problem we have taken, and this methodology will be implementing. So this is from the vast literature. We have identified nearly 13 drivers of greenwashing. So I am not going deep into the drivers of greenwashing because that it is not of our interest, because we are only this video is only for the implementation of the methodology and for the understanding of the researchers and practitioners. So these you understand that 13 of the major drivers of greenwashing has been identified for the problem, and we will be working on this problem. Okay, so I will be showing 13 drivers. These are the 13 drivers we have identified. I will just read out the names. Okay, one is uncertain regulatory environment. Next is the activity NGO and media pressure, then consumer induced incentive and the investor induced incentive, then competitor induced incentive, then film characteristics, then incentive structure, then the ethical climate of the film, the organizational inertia, the effectiveness of intra-film communication, then narrow decision framing and hyperbolic intertemporal discounting and the optimistic bias. So these are the identified factors from the extensive literature we have identified, and we wanted to identify the causal relation among these factors. Okay, so we can use the same methodology. I already told we are using 1 to 5 scales. We are collecting the responses from very low to very high. Okay, so we have used the respondents which are having a minimum of PhD degree, so that in management, so they are industry experts also. So why? Because we are getting a response which are the cleaning responses will be a heavy task. So instead of that, we have taken responses from experienced and more educated persons, so that they will be more knowing about the situation of greenwashing and the drivers. Okay, because these are all mostly with the technical terms only, so that's why we preferred like that. So 100 respondents we are sending, we collected 62 responses, and sorting we found that 6 of the responses were not good. We have eliminated them also, and this is the cleaning part. We already told we have to clean the responses. So 56 responses we finally got it, and it is very difficult to implement any ISM or Mattel model with 56 responses. Okay, so because we are averaging the responses, there will be no use, because it will not be the response recorded by the respondent 1, or it may not be the response recorded by the respondent 56th respondent. It may be some average value which may not indicate any clear specification about the influence relation between the drivers. So this is the case where we wanted to have these kind of particular techniques where large number of data is there, data points are there, or survey data is there. Then we can have more accurate information regarding the influence of a factor over the other, because more people have recorded or responded to that. So how will be representing? So we can see that the cumulative scores, we are seeing that these are the conversion scale. So very low indicates 0 to 3, low 2 to 5, medium 4 to 7, high 6 to 9, and very high 8 to 10. So this gray scale we have taken randomly, and we are whitenized the responses. Okay, so already we told for whitenizing the responses, what we will be doing, we will be taking the sum of the lower bound, sum of the upper bound, and we are taking the average value of this, and we are taking the cumulative sum of that. Okay, so this is the way we will be whitenizing, and I will be showing that. See, there are 3 matrices. One is the critical one, ideal one, and the most typical one. So how will be taking? We have 56 response. We have taken the sum of the values, or sum of the values of the lower bound, what that represents the critical model whitenization of the model, and some of the values in the upper bound, that will be representing the ideal model whitenization, and the average of these values that we normally do for any kind of usual input, that also we are taken as the one input, that we are taking the average of the lower bound and the upper bound. Again we are taking the sum of all the 56 responses. So now we have 3 matrices, right? Okay, so these 3 matrices we have. Okay, this is one graphical representation of the cumulative responses. Okay, for these are the drivers, and based on the influences are shown here. So this is one of the representation of the influence relation among the factors. So the outer ring represents the influencing power of the drivers. Okay, and this we are indicating the most typical values of the aggregate responses we are indicating. Now we have to calculate the direct influence coefficient, right? So we can put it to the equation, and you can the equation you can solve it for the direct influence coefficient matrices, and we can calculate the direct influence coefficient matrix. Only thing is that there are 3 set of values, right? So 13 factors are there. So 13 in the row wise and 13 in the column wise we have to plot, and all the responses we are converting as the direct influence coefficient matrix. Okay. Now what is the next step? So there are 3, every time there will be 3 set of matrices. One is the critical value corresponding to the matrix, the second is the matrix corresponding to the ideal values, and the third is the most typical values. So 3 matrices are there. Okay, influence analysis. So there are 13 factors we are putting in the row wise as well as in the column wise, and we are indicating the influence of one factor over the other. Okay. So this is the way we will be indicating the values, and further calculate the complete influence coefficient. How will be calculating the complete influence coefficient? We already shown with the equation 13 and 14. You can refer to that equation. We will be calculating the complete influence coefficient. Okay. Now we have complete influence coefficient also. We have what we have? We have 3 values. What is that? One corresponding to the ideal model, second corresponding to the critical model, and third corresponding to the most typical model. So these values will be getting, and now how will be calculating the total influence coefficient? Total influence coefficient you can use. Here I am using the value of L equal to 1. I already told the L can be varying from 1 to 6. So L equal to 1 means that here we are taking the sum only, like 1 weight we are giving to the critical model, 1 weight we are giving for the ideal model, and 4 weights we are giving for the most typical model, and we are taking the sum of that, and we are not dividing because L equal to 1 means that divided by 1 only. So we are taking the sum of that, and L you can fix according to the need of the study. Okay. So this is our further analysis. Pareto principle we are applying, that is top 20% of the factors. So there are 13 factors involved in the study. So top 13 we can it will be coming value 2.6, you can round it to 3. So top 3 factors we can identify as the main factors which are involved in the study. So these factors we are getting for the particular purpose as film characteristics, okay, then uncertain regulatory environment and optimistic bias. Okay, so these 3. So we can say that the uncertain regulatory environment and the optimistic bias can be at the second position. Okay, so film characteristics are the primary or the most important factor which is determining the driver as a chief driver, making the films to greenwash. Okay, so the characteristics of the film, because the size of the film, a number of employees, these are directly dependent on how the film behaves to the public, or how they will try to greenwash. Okay, so this is the result we got it from the model and from the responses and for the case study. So these results we are indicating in a graph type manner, so that it will be more clearly visible regarding the ideal, critical, and most typical values of the gray influence coefficient, gray responsibility coefficient, and the total influence we are indicating. Now we are having the gray responsibility influence and total influence coefficient we are representing, and based on that, this table 6 is representing that. Based on that, we identified the most important fact in the system. Okay. Now what about result and analysis? I already told regarding we are proposing that the methodology is being proposed as a new methodology where the other conventional methodologies will fail to incorporate large amount of data in case of causal modeling techniques, because usually they are doing averaging of the responses, which may not be helpful when there are large number of responses, because you will be losing the data. Okay, so this is the main problem with that cases, and some of the implications of the case, why these factors are coming important, and what the managers can do by identifying the drivers of greenwashing, or why the problem is important, and what are the major practical implications of the study. So that all are indicated. So I am not going deep into that. So some of the implications here it is shown for the study. Okay, so main thing is about the cumulative aggregation of responses using the GINA or the gray influence analysis can avoid loss of data while aggregation. So this is very important, and the methodology can incorporate large amount of data. And mainly we are focusing on the problem of greenwashing, drivers of greenwashing, and the influence among the drivers of greenwashing. This problem is not addressed in literature. So the problem as well as the methodology are, the problem as well as the case are new in our study. So we are given some of the implication to practitioners as well as to the researchers which are trying to implement gray influence analysis. Okay. So I hope this lecture is clear for you regarding the implementation of the GINA or the gray influence analysis. So this is a new influence or causal analysis techniques where this very simply we can implement, and you can successfully incorporate a very large number of any number of responses, very large number of responses. We have used only 56, but more responses we can accumulate because we are making the responses in the linguistic scale, because usually they will be giving very high. You cannot give a crisp value. Simply you cannot assign 5, because for my case very high will be 8, and some other person opinion very high will be 10. So that's why we are fixing a limit, and we are calling, or we are using the gray theory to handle with that. So it is a kind of an interval value that is varying between 8 and 10. So very high can vary from person between 8 and 10. So that's the way we will not be losing any data, and these data will be converting, we are aggregating through 3 different models. One is the ideal, another is the critical, and third one is the most typical models, so that we will not be losing the data, because we take the sum of the lower bound, sum of the upper bounds, and the average value or the middle value will be taking, or the most typical value will be taking, and we will be assigning weighting for this, because we are assigning 1 weighting for the critical ideal, and we are assigning a higher weighting of 4 for the most typical value, and we will be aggregating the responses. So these responses we can input for the GINA model, and you find out the factors. Okay, so direct influence coefficient, and based on that finally we will be calculating the total influence coefficient. Based on that you can understand which are the factors or the drivers or the enablers or the barriers which are having key importance in the system, or which are playing a key role in the system. Either the factors which are getting influence, or it is influencing a lot of factors in the system. These factors we can say it as they are important to a system. So this is the implementation and a sample problem with the gray influence analysis. I hope it is clear for you, and you please, if it is interesting, you try to implement the problem given in the paper, as well as you can implement for smaller problems, and you can use it for the original research problem formulated in your study. Okay, thank you. I hope all of you will be using and referring this technique in your causal modeling situation, in particularly for the supply chain and marketing related the researchers who are working in these domains. Okay, thank you once again. Okay, thank you. We will come with a new video next time. Okay, thank you.